This is my cat Smudge, and here's how he solved an impossible math problem. The problem he solved today was the Collatz conjecture, also known as 3x plus 1, and it has been unsolved for the past 86 years. It has very simple rules. Think of any number. If the number is odd, multiply it by 3 and add 1, or if it's even, divide it by 2. Then repeat this for pretty much forever. Let's use 5 as an example. It's odd, so we would multiply it by 3 and add 1, which gives us 16. 16 is even, so divide it by 2 and you get 8. 8 is also even, so we would divide it by 2 and get 4. 4 is even, so divide it by 2 and you get 2. 2 is even, divide by 2, you get 1. Now 1 is an odd number, so you would multiply it by 3 and add 1, and this gives you 4. This creates the 4 to 1 loop, where you endlessly have 4 going back to 2, going back to 1, which goes back to 4. And the conjecture states that all numbers will eventually go down to the 4 to 1 loop. If you find a number that does not go to this loop, or if it shoots off to infinity, then you have disproved this conjecture. To prove the conjecture, prove that every single number goes to the 4 to 1 loop. Everyone was telling me not to try this problem, but it looked interesting, so I did it anyway. I coded up a simple Java program to calculate the answer given any number I start with below 200,000 digits using big integer. I was then going to add it to a polar plot so I could see the glide of every single number and have it on a chart. And hopefully I could find a pattern. However, I got bored while I was making this, so I just went to a random website to try out some random numbers because I thought that might be fun. After doing this for a while and getting no interesting results, I decided to go refill my water bottle while my cat Smudge stayed at my desk. He made himself comfortable, and he sat on my keyboard, holding the 9 key. When I returned, I thought this was a little silly, because it's just a whole bunch of 9s spammed into the program. But I tried it anyway, because it was a number. To my surprise, it resulted in an incredibly high glide number, and I was a little surprised that such a good number could be so easy to find. I experimented with this number a little more, and then I found a pattern which would eventually lead to infinity. However, the website I was using was not strong enough for my calculations, so I went back to my Java program. My friend Lily helped me by adding their computer's power to calculate a huge number with me. We spent 2 days calculating an absurdly long version of Smudge's number. The calculation went hundreds of thousands of digits higher than it started, before it eventually went back to the 4 to 1 loop. Calculating any bigger than this would be a waste of time and resources for us, so instead I made a formula to determine the glide number it should roughly have. This is the equation. The trend is that for each time I double the amount of 9s, the glide will roughly double as well. For graphing, it's roughly a linear graph starting at 0. Add 3 glide for each extra digit of 9 you add, and that'll give us a slope of 3x, and a y-intercept of 0. Given infinite amount of 9s, the glide would also pretty much reach infinity. I will call this Smudge's number because I feel like it. Considering how this number can have a glide of infinity, infinite other numbers also have pretty much an infinite glide number, and this could create a separate loop from 4 to 1, if they loop into each other. However, my computer is not strong enough to do any of that, so if anyone who has access to a supercomputer or something would like to try a huge number of following this formula, then go right ahead. Credit would be nice. And that's pretty much all I have for this video. However, I did not finish my first idea which I was planning. I saw a video about the prime spirals, link in the description, which clearly plotted the numbers in a polar plot, whether they were prime numbers or not prime numbers. It showed patterns which looked really cool and taught me a little bit about prime numbers. I wanted to do this, but with glide numbers. However, I was unable to. So I'd be glad if someone else could do this and show me it, or just make a video about it, because it might look really interesting, and it could even show you some cool patterns. Anyway, thanks for watching, and I'll see you guys in the next one. Bye!